Hello dear students, today I will discuss about axiomatic approach to probability. So axiomatic approach to probability, just we have to define how can you find the probability of an event and what is the axiomatic approach. For axiomatic approach, just up to now we are finding the probability. In the previous class also you find probability when we know that the total number of outcomes and favorable outcomes, total number of outcomes, when we know the total number of outcomes, okay, that is all the sample points corresponding to a sample space, that is corresponding to some experiment. We are having sample space, and sample space means sample point. There are some elementary events are in sample space, and sample points are these events are called sample space. And what are the probabilities for happening of the each sample point? Each sample point. Okay, this is the assigning probability to a particular sample point, which is a particular elementary event. Up to now, we are supposing that all the elementary events are equally likely. That is, chances of happening of each outcomes are same. Chances of occurrence of the events are same. That is equally likely events. Okay, but axiomatic probability, because it is not possible every time that experiment giving outcomes that are having same chances. Okay, so in axiomatic probability approach, just we are defining probability to each sample point, and also axiomatic approach is defined like probability assigning, because sample space having sample point, each point, what is the probability of happening of elementary events? That is one outcome. Okay, so here probability of the occurrence of an event or non-occurrence of an event is a real valued function, we can say, because generally event, what are the events? Event means any subset of sample space. Suppose we are having sample space containing some points, then any subset of sample space is called an event. Any subset, this S is sample space, then any subset of this, how can we write? PS. What is? Power set. Power set of S. Where S is sample space. PS. This is the domain. This is the domain of a function. If, because this is power means it contains all the subsets of S. That is what? Phi, also S, also all the subsets of S are contained in PS. Okay, maybe A, B, C, all are subsets. Also these two also included. So all the subsets of power set. So these are maybe the events. So we are finding probability of P phi, PS, PA, PB. What? A, B, C are subset of S. So this gives the probability of any event. Any event is what? Any subset of S. So we can define probability as a real valued function, but its range is what? 0, 1. That is PS power set to 0, 1. Probability P is a real valued function as this, satisfying following axioms. Here, axiomatic probability approach. Probability means probability to an event, any subset. All the sample points are just taking single sample point. Suppose we are having sample space having 3 points. Suppose S equals to omega 1, omega 2, omega 3. These are sample space. 3 outcomes are there. Then what? Phi is subset, maybe an event. S itself is subset, maybe an event. Omega 1 singleton. Each singleton also subset, and 2 omega 1, omega 2 is a subset also. Omega 2, omega 3 is a subset also, and omega 1, omega 3 is a subset also. All the subsets, just all the subsets, these are the sets, and also omega 1, omega 2, omega 3 itself. Actually we are finding probability of omega 1. That means what? It is for convenient to write like this. Probability of this means what? When this outcome will come. But this outcome, this is short writing. Actual writing is this. Event omega 1. Set having single element omega 1. Its probability. This both are same. This is for convenient we are writing like this. Okay. Omega 1, omega 2, omega 2. That means like this. This set. Maybe we can say this is A, this is B, this is C, 2, 2, and total 3 means S itself, and 5 nothing. So this set, this is what? Power set of this, because we are finding probability of like this, of this event. So function from here to its value will be what? A real number lying between 0 to 1. So probability is what? This PS means what? Power set of S. Here PS means power set. Power set of S. This power set of S. This to this. This is a function, because this is function P. Just here, one of the point from here will be this real valued function and containing its value in 0, 1. That is this. Suppose omega 1. So any of the point subset here. Then this is what? 0 to 1. That is its value is 1 is less than like this. Okay. So here generally we are defining approach to probability. The probability P is a real valued function as P defining from PS to 0, 1, satisfying following axiom. This axiomatic approach, so some of the axioms should be satisfied by this function. That is what? First axiom is what? For any event. What is event? Event is any subset, just like we are writing here. Any subset of sample space. For any event, E means any subset of S, sample space, corresponding to a random experiment. E. Probability of this E is greater than equal 0 because lies between 0 to 1, greater than equal 0. Second, following axioms must be satisfied. Then we can find the probability. Axiomatic approach is this. In the higher classes you will find probability by using this. Here, for any type of events, equally likely, may be equally likely, may not be equally likely, because sample space having points that are equally likely or not, just we are defining probabilities to each sample point in such a way that probability of sum of the probability of all the outcomes, all the elementary events should be equals to 1. So that is this. Probability of sample space is equals to 1. It means what? Sample space probability of the event where it containing all the outcomes. And third, if E and F are two mutually exclusive event, then P E union F is equals to P plus PF. Here see, mutually exclusive event, because we know sample space is there, any subset of sample space is subset, and EF are two events, suppose any two events, that is subset, any two subset, and they are mutually exclusive, they are disjoint. Mutually exclusive means disjoint. Then union of that two is equals to PE plus PF. These three conditions, these three three axioms must be satisfied by the probability assignment property. How can we assign the probability to the sample points of a sample space corresponding to a random experiment? Because we are doing any experiment, then we can get a sample space. Sample space means set of all possible outcomes, possible results. So for each possible outcomes, what will we assign probability for happening of each point, that is of each elementary events. Assigning should satisfy this. Sample space having all the elementary events. So probability of sample space, because probability of an event, sample space is also an event, all the outcomes, either of these outcomes. Okay, for any event, probability should be greater, positive, greater than equal to 0, and total probability equals to 1. And if two events, any of two events are mutually exclusive, then union, probability of their union is equals to sum of the separately probability. Clear? Here, if sample space are having omega 1, omega 2, omega 3 up to omega n, this is sample space. If sample space is this, containing n outcomes, these are the outcomes. sample points, elementary events, if sample was containing these events. Then from this definition, what we can observe? This definition, probability should be greater than real valued function, a real valued function, a real value between 0 and 1. So first, then according to axiomatic, probability definition. Axiomatic probability definition. This is axiomatic probability definition. From this, if sample is having these sample points, elementary events, then what do we get? First, 0 less than probability of, means probability of each outcome, each elementary event should be lies between 0 to 1. Okay, for all omega I belongs to S, for all. Clear? Second is probability, total probability. Total probability means probability of this plus probability of this plus probability of this plus PS equals to 1. From this probability of omega 1 plus probability of omega 2 plus up to probability of omega n is equals to what? 1. Total probability 1, probability lies between 0 to 1. Third, here main thing, event may contain, any event may contain single outcomes, may contain 2 or 3 or 4 or total outcomes. So for any event A, for any event A means A may be omega 1, omega 2, omega 3, also combination of 2, 3, 4 and so on. For any event A, probability of A, that is probability of A is means what? Because any event may contain 2, 3, 4, 5, 6 and so on. So probability of A is equals to what? Sum of probability of omega I for where omega I belongs to A. See here, probability of an event is defined. How? If an event contains outcomes, just like suppose, for example, suppose an event contain, an event A contain omega 1, omega 2. Two outcomes are having there. Then this event also A may be what? Omega 1 itself. So probability of A means if this, then probability of omega 1 only. If this, then probability of omega 2. Because sum, how many elementary events are in A? So sum of all probabilities of all the elementary events. So if this is event, then probability of this event is equals to this. So this is the definition. So this is our axiomatic probability approach. Axiomatic probability approach. Clear? So axiomatic probability approach is this. This exam should be satisfied, and from here we are seeing, you see that probability lies between 0 to 1. Probability, total probability is equals to 1, and event, for any event probability of A is equals to defined like this. P omega I, where omega I what? Sample points which are in the events A, because event subset of sample space. So A can contain single element, 2 element, 3 element, 4 element and so on. Okay. Also from here we can see that if two events are mutually exclusive events, also all the possible outcomes itself they are mutually exclusive, because outcome is two outcome. Pairwise this elementary events are mutually exclusive. If mutually exclusive, then the probability of this all can write like this. That's why we are getting probability of this, because event having maybe 2, 3, 4, 5, 6, 7 up to 10. And probability of this, that means what? In the events, the outcomes are having elementary events, so they are mutually exclusive. That's why union of that elementary events is equals to what? A. So probability of A is equals to sum of the probability. So from here we are getting like this. The third is getting PS is we are getting. From this we are getting this, because from this, if suppose F equals to 5, then if F equals to 5, then what we get? PE union 5, PE equals to PE plus P5. So PE cancel, so PE F P5 equals to 0. So impossible event having probability 0. So 0 is less value and greater value is 1. Sure probability. Okay, any of the outcome will come. So any of the probability, surely we can get the sum of this is equals to 1. So we are assigning now probability to the each outcome of sample space in such a way that they will satisfy this two condition. Then we can say the probability assignment is valid. For validation of probability assignment to the sample points, because if equally likely, then we know that if each outcomes having same probability, because chances of occurrence of coming any of the outcomes are same, that is equally likely events having same probability, but maybe not same, then just we are assigning the probability to each outcomes, each elementary events is sample point in such a way that this two condition will satisfy. Then we can say the assignment is valid. Okay, should be positive, lies between 0 to 1, sum of all probability is equals to 1. Then you can say the probability assignment is valid. Okay, so just see question 1 of exercise 16.3. Here question 1 of 16.3 is given. Which of the following cannot be valid assignment of probabilities for outcome of a sample space? Here sample space is given, omega 1 to omega 7 are the outcomes, and assignment means we are giving the values of probability to each sample point in such a way that these two conditions must be satisfied. Then we can say that assignment is valid. Okay. Or if not satisfied, then assignment is not valid. Okay. So here given that sample point having 7 points and corresponding to 7 points, the assignment of probability is given in a tabular form. So this in this table, just we see the first assignment A. First assignment A is the assignment to the assignment A, B, C, D, E. Up to 5 assignment are there. Okay, and probabilities assignment are given row wise. First assignment, second assignment, third assignment. Just we are giving the answer whether these assignments are valid or invalid. Okay, so first assignment having values what? 0.1, 0.01, the C. Because here what we are doing? Just assigning probability to the sample points of a sample space. What may be the probability for the? So here solution, just consider question 1. Okay, here sample space are having omega 1, omega 2 up to 5, omega 6, omega 7. This is given here sample space omega 1, 2, 3, 4, 5, 6, 7. 7 some elementary events, 7 sample points are there. Assignment. A. Assignment is as follows. Means what? Omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. Okay. Sample points. Probabilities. First probability, what? 0.1. Second, 0.001. Just see here. Omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. Just like this. Okay. So first probability 0.1, second probability 0.001, and 0.01, 0.05, 0.01, 0.05, 0.03, 0.03, 0.01, 0.2, 0.6. What is the meaning of this? Omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. What? These are the sample points, possible outcomes of an experiment. Just like sample space containing these outcomes, elementary events. Just give an assignment. How? For happening this, for getting this outcome as a result, what is the probability? Just be assigning probability 0.1 here. For this 0.01, for this 0.05, for this 0.03, for getting this outcome as a result, probability, corresponding probabilities are there. Just this is an assignment. The assignment is as follows. First assignment. Whether this is valid or invalid, just we are trying to giving the answer. So we know what we know for axiomatic probability definition. The probability should be greater than or equal to 0. Clear? So here we see that each value are positive. Okay? This is omega 1. This notational value is what? P omega 1. P omega 1 means this. P omega 2 means this. P omega 3 means this. P omega 4 means this, and so on. What is this? P omega 7. Okay. So here we see that each value P omega I equals to 1 to up to 7. Each value, this each value is what? Each value, this is positive. This value is positive. Clear? Positive and also lies between 0 and 1. That is P omega I like this. So this first condition satisfied. Now and also second condition, sum of this total values, sum of P omega I equals to 1 to 7. Here 7 value is this. So this is equals to what? P omega 1 plus P omega 2 plus up to what? P omega 7. So just sum of this total. Okay. So 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.2 plus 0.6. Just sum of this. Okay. So here what will be the value? Here see 3, 1, 3, 4, 5, 9, 1, 10, 0, 1, 6, 7, 8, 9, 10, 1.00. So this is equals to 1.00. That is what? Equals to 1. Clear? This sum of total probability. Total probability 1. So second condition, this is first condition. So both the condition for axiomatic definition of probability are satisfied. Hence, the given assignment is valid. Given assignment is valid in the A option. So this is the process for giving the answer whether this is valid or invalid. Valid means each probability should lie between 0 to 1 and total probability, sum of these probabilities is equals to 1. Then if these two conditions satisfies, then you can say the given assignment is valid. Okay. So see second assignment. Okay. Here just see second assignment is what? Second assignment Omega 1 by 7, 1 by 7, 1 by 7 of each. So 1 by 7 lies between 0 to 1. Okay. B, assignment B. What is given? 1 by 7, 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 1 by 7. We know that 1 by 7 is less than equal 1, less than 1, greater than 0 also. So we see that this, right? And also sum of this. We know what? 1 by 7 plus 1 by 7 up to 1 by 7, 7 times. 7 times. That is equals to what? 1 by 7 into 7 is equals to 1. Right? This. Both are right. Valid statement. Second is also valid. Okay. Third. What is third? Third is 0.1, 0.2, 0.3. Third is 0.1, 0.2, 0.3 and 0.4, 5, 6, 7. 0.4, 0.5, 0.6, 0.7. These are given. Okay. So yeah, first condition is right. First condition is right. Positive. Because all are less than equal, less than 1. All are less than. But second condition here we see that second condition is what? 0.1 plus 0.2 plus and so on 0.7 is equals to 2.8. 2.8. Just sum up this, you can get sum of this 2.8. This is not equals to 1. This is not equals to 1. So, second condition is not satisfied. Both condition of these are not satisfied. Are not satisfied. Is not valid. Is not valid. Assignment is not valid in third. Okay. D. Fourth. So see here. Fourth are what? There are some negative assignment. What? 0.1, 2, 3, 4. So like this. Minus 0.1, 2, 3, 4 and minus 0.2, minus 0.2 and also 0.1, 0.3. This type of assignment are given in option D. So here negative, so this is not satisfied. Okay, here we see that each value is, here we can say that just you can give the answer in detail for writing about here. Here P omega 1 and P omega 5 are negative. So first condition is not satisfied. So assignment is not valid. First condition is not satisfied. E is given. E is given E is given 1 by 14, 2 by 14, 1 by 14, 2 by 14 and 3, 4, 5, 6, 3 by 14, 4 by 14, 5 by 14, 6 by 14, 15 by 14, 15 by 14. Okay. Here P omega 7 is greater than 1. P omega 7 for 15 by 4. What is 15 by 14? This is greater than 1. So assignment is not valid because first condition is not satisfied. Less than equal 1. So here greater than 1. So not valid. And assignment is not valid. These are the option for assignment and we are checking one by one whether valid or invalid. So you can give the answer by testing for satisfaction of two conditions. First, P omega I lies between 0 to 1 and total probability should be equals to 1. If both conditions satisfied, then you can say valid assignment. Or if any of the condition is not satisfied, then not valid. Okay. So this is what? Assignment of probability to the each outcome of sample space, that is each elementary event. For assignment of probabilities to each elementary events of a sample space corresponding to random experiments. Okay. So whether assignment is valid or not valid, you can give the answer. So do some questions related to this definition. How can we check whether assignment is valid or invalid? Some examples, answers, do some questions and send me 2-3 questions for your attendance. Okay.